Hello. Well, today we're gonna explore how an animal detection vision model works with some chosen pics and the relation between AI pictures and real world images. The model that we are gonna use is the RoboFlow. This is a platform where you can find uh, many type of projects models to recognize objects like rock, paper, scissors, license plate recognition, people detection, face detection, and so on. In this case, we're gonna use the animal detection computer vision model. These are the metrics of the model, which have 90% precision. This model um, have a lot of animal classes, which is like bear, buffalo, camel, cat, cow, deer. And for the exercise, we're gonna take um, 5 pictures of AI generated images and 5 pictures of real world images. The AI um, generate images was generated by Deep AI, which is AI image generator, uh, and this is the prompt that we use to recreate these images. So actually, it's ultra realistic photograph of this is the animal that you pick in its natural environment, realistic proportions of anatomy, and so on. Okay, I chose 5 types of animals: a dog, a cat, tiger, shark, white shark, and a polar bear. Um, Also, I chose random pics of the same animal in Google: a beagle, a dog, a cat, the same tiger, a shark, and a real bear. Okay, so how does it work? Okay, you pick here, click here, and try this model. Shows the image. For example, I'm gonna choose the cat images, and the model is gonna predict what is the picture uh, on the model. So in this case, the model predicts that this is a cat with 90% um, of confidence. So I repeat this process with these 5 pictures, 10 pictures actually, and this was the results. The comparison results are how I structure the table. Well, this is the image name, the actual class, predicted class, confidence scores, AI generated or real, and the accuracy. So most of the images was correct, um, but I have like 3 images of the 10 that was incorrect. In this case, the real dog that was identified as lion with 66% of confidence. Um, Another pick was the shark with was recognized as a code with 68% of confidence, and the AI shark with 62% of confidence recognized as a cat. So and overall, the observations and the insights about accuracy comparison, while the real images we have 3 out of 5 correct, so we have 60% of accuracy. The AI images 4 out of 5. Uh, I could say 80% of accuracy. So the insight is like the model, the little bird AI generate images than real ones. Um, this could mean that the AI generator makes idealized versions of these animals that are more like the training data for the model than the messy versions you see in real world pictures. About the confidence scores, well, the average confidence score in AI was 74%, and the confidence in real was 78%. So, what does it mean? Well, the model was generally more sure of the real images, even when it was wrong. And I mean, we have a shark identified as a goal that was wrong, but with a higher percentage of confidence. What does means, or why does it happen? Well, the model um, see the signals in real images because they usually have consistent textures and lighting. Um, in the other hand, the AI generated images are usually accurate in shape, but they may have small artifacts or textures that can make the model less sure of itself, even if the main subject is clear. Well, the common error that we have in the model was, okay, the shark problem. Neither the real nor the AI shark was identified, so um, I could say that the model uh, might not work well with aquatic data sets, or might be confused about the blue background or the water textures that the image have. So for default, uh, take like the more common land animals to represent this failure. Um, the visual similarity in the real dog that was identified as a lion, probably because of the colors. So, or probably that breed of dog doesn't have many training in the model. So, probably this is a certain mistake. The low confidence success, well, the AI dog was correct, but only with 44 confidence. So this indicates the model barely passed that image. So even though the model recognized that it was a dog, exceeds a 66% of doubt about that model. So uh, what does it means? The model uh, is lack of training in this type of dog. So, okay. What are some applications in real world of these classification models? Well, one of the applications may be automated wildlife monitoring, in which the researchers users as motion active camera for drone to monitor species in a specific area. This could be an improvement because it automates the hours of films and allows for better identification and tracking of the population in wildlife environments. Another application could be the zoo management, which allows you to count the population of your zoo, identify specific behaviors that provide information of the health of the animal, the population, or even a specific warning about the animal. Um, Another question is how AI generate data could impact the model performance and training. Well, normally the AI or synthetic data is a high quality for traditional data sets. So it helps the developers or whoever who is designing a model speed up in the development by making millions of perfectly labeled samples in seconds. Uh, it also gives you important strategic advantages. First, it protects people's privacy because the data isn't linked to real people. Second, it helps reduce bias because datasets can be made to include all the groups that aren't well represented or are rare cases which makes the training data more balanced and fair. Um, Also, these benefits are especially useful in wildlife applications, as we talked before, where real world images are often affected by environmental noise like bad lighting, small object sizes, camouflage, uh, weather conditions, and so on. So researchers can deal with this problem by using static datasets. So they can focus on the most important shape of the animal to train the model. Um, but even though there are benefits to using all the synthetic data, there are also risks such as overfitting, learning fake patterns, or missing out on the real world details. Um, that repeated exposure to synthetic samples can also cause the model collapse, which is when the output becomes narrow and repetitive. So, what is my advice here? Try to focus the strategy in a hybrid training. You can start your pre-training on synthetic data to analyze the shapes, the patterns, the colors, and uh, specific topics about the animal, specific types of animals, and then you go further and start training the model with fine-tuned details about the real-world data that is the high-quality data to train your model. That helps you to close the gap between simulation and reality and perform well in realistic complex environments by using both sources. So this is my resume about the animal detection computer vision model. Uh, you can use it. It helps you a lot. You also can use AI tools to generate images. And here you have the link of the AI tool with um, used to compare the pictures and understand the insights about that specific model. You can use it obviously in any other models that you want to train, but here you have a good example of it. Thank you very much. Bye bye.